Hello students, let me introduce myself. My name is Naveen Kumar HJ. I am going to teach you mathematics. Children, first chapter. So what we have in 9th standard, number system. Okay, so today we'll start number system introduction. Okay, so what do you know about numbers? Can anybody tell me about numbers? In your class 8 you have learnt about numbers, right? Can you able to tell me what are the different types of numbers? What are the different types of numbers? Is it? What are the different types of numbers? Whole numbers, natural numbers, integers. Okay. What do you mean by natural numbers? Natural numbers are the numbers which starts from 1. See, we can also say counting numbers. Okay, you count the numbers from 1, 2, 3, 4, 5, 6, etc. That's what counting number. Okay, now you can see on the screen number system. Okay, let us introduce number system. Number system means it is a bag full of numbers. We have a bag full of numbers, but we need to take different types of numbers from that. Okay, so what type of numbers you can see there? Rational numbers, integers, real numbers, and irrational numbers. Okay, so this is how you have learned from your 8th standard. Okay, so let us start with the joke. Can you see the joke? Okay, now the first joke: why did the teacher wear sunglasses to schools? Okay, so why? Because her students were so bright. Okay, then why was the math book sad? Actually, math book is sad. Why? Why? Because it had so many problems. It had so many problems. What are the strongest days of the week? What are the strongest days of the week? You might be knowing it. What are the strongest days of the week? Okay, Saturday and Sunday. Okay, so why? Because the rest are weekdays. The rest are weekdays. Children, here is a puzzle. Can you solve this puzzle? You can see this. A puzzle is there. Okay. You can observe that 5, 1, 16, 11, 4, 49, 18 star 121. Okay. So what number should come in place of star? Can anybody guess? You can also see how do you get that. Is it? Okay, so now we'll see that the first is 5 minus 1 is 4. 5 minus 1 is 4. That can be written as 4 square. 4 square is equal to 16. So 5 minus 1 is 4, and that is 4 square is equal to 16. Then 11 minus 4 is 7. 7 square is 49. Then 18 minus 7 is 11. 11 square is 121. So simple. Okay, so answer is 7. So 7 should come in the place of star. Okay, do you all know about the magic squares? Okay, magic square. Okay, 1, 2, 3, 4, 4. That is you need to add those number row wise, column wise, and diagonal wise. You must get the same answer. So in your 8th standard, so play with numbers. In that chapter it is there. Children, all these things, sir, you have to learn because it will increase your enhance your memory power. Okay, and also the concentration. Children, here what do you mean by logic square? Logic square means rearrange the number 1 to 9 such that sum of 3 numbers in all columns, in all rows, all columns and both the diagonals equal to 15. Okay, so here what will happen? 1 2 3 4 4 5 6 7 8 9. Okay, so 1 2 3 4 5 4 4 5 6 and 7 8 9 is arranged like this. You need to arrange this as some numbers row wise, column wise, and diagonal wise. You must get 15. Okay, you must get 15. So try this, because you can do many ways. Try this. Now here is the answer. How we are going to write? 2 first, 7 second, third one is 6. First row. Second row 9 5 1. Third row 4 3 8. So you can see there, when you add row wise you will get 15. What is 2 plus 7 plus 6? 15. What is 9 plus 5 plus 1? 15. 4 plus 3 plus 8 is 15. Again you can see 2 plus 9 plus 4 column wise I am telling. That is also 15. 7 5 3, that is 15. 6 plus 1 plus 8, that's also 15. So you can see, anyways you are adding row wise and column wise, you are getting the same answers, that is 15. You can also see the diagonal. You know diagonal? Diagonal means it's a you can see in the square diagonal will be there. 6 plus 5 11. 11 4 15. Again you take this type diagonal. 2 plus 5 plus 8, that is 15. So this is how you can do magic square. Children, if you solve these type of puzzles, you will get refreshed, and also you will be very interested to learn maths. Children, do not worry about the maths. Maths is very easy subject. So we are going to try to make the subject easy. Do not worry about that maths. You must have the interest as well as a love towards the subject. Then only you can learn the any subject, not only the maths. Okay. So try to, if you do not know, you just try to search, and also try to do the problems, so you will get answers. Okay. So you clear with the puzzles? Okay. Next, we will start. Recall. We recall what we have learnt in 8th standard. Okay. So what we have learnt? We have learnt different types of numbers. Those are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Okay. So these are the numbers we have learnt. First of all, we will see what are natural numbers. See children, natural numbers. The counting numbers 1, 2, 3, 4, etc. are called natural numbers. The set of natural number is denoted by n, letter n. Thus, n is equal to you can see that 1 2 3 4 flower bracket 1 2 3 4 and 4, and it will go like up to infinity. See children, the least natural number is 1 and the greatest is infinity. Here the infinity means, so undefined means we cannot say largest natural number. Okay, we cannot count also. So if it goes on counting, it never ends. That's why you never count the natural number. Children, a daily life example, you can see natural number in the bank counting money. Okay, who is counting money in the bank? Cashier. Okay, cashier will count daily, he counts the money. Whenever the cashier counts the money, what he will do? He will start from 1. Okay, 100 rupees note also he will count as 1 2 3 4 5 6 like that. So you can also count. Okay, whenever the counting, for example, number of students in the classroom, count the number of students in the number of laddus in the bakery. Okay, so you can count, right? You always start from 1. So always start from 1 is called natural number. Okay, now I'll give a counting activity. See children, how many faces can you see this in the tree? See, these are all faces. It's recognized, right? So they are freedom fighter, freedom struggler. You will be able to see that so many faces are there. Okay, you just count it. Okay, I'll ask later how many are there. And adjoining figure, there is a cube. Okay, How many cubes are there? Can you tell me how many cubes are there? Count. These are the counting activities. You need to count. Then you will increase your concentration level. Okay. So that you just count it. How many are there? How many faces are there? How many cubes are there? And here you can see how many faces of tiger you can see there in the picture. How many faces of tiger? Okay, can you see the picture of tiger? There are a number of tigers are there, and also faces of tiger which is hidden. Okay, that you can see. Got it? Okay, you can do it later. So number of faces. So these are type of something. It's really interesting, right? So you can count it. You can also see the beauty of the tiger. Okay, you know that the tiger is an endangered animal. So nowadays number of tigers are decreasing. From the census we can see that there are 2000 tigers in our India country. So number of tigers you can find out. Okay, so now let me see the properties of natural numbers as follows. So we will quickly recall. The natural numbers also called counting numbers. The first and smallest natural number is 1. Is it right? Every natural number except 1 can be obtained by adding 1 to the previous natural number. Isn't it? So you will get next number by adding 1, no? So for example 3. When you add 1, what you will get? 4, like that. For natural number 1, there is no previous natural number. So previous natural number is not there because 0 is a whole number. We'll talk it later. There is no largest or least or largest natural number since they are infinite. Natural numbers are denoted by n normally. We cannot complete the counting of natural numbers. We express fact by saying that there are infinitely many natural numbers. Got it, children? Okay. So next we'll go to whole numbers. What do you mean by whole numbers? Zero and natural numbers together called whole numbers, isn't it? Actually, natural numbers are there and zero are there. Zero are there and natural numbers are there. Okay, when you add zero to the natural number, you will get whole number. Isn't it, children? Okay, so what is natural number? Natural number is counting number. When you add zero to the natural number, you will get whole number. The number 0, 1, 2, 3, 4, etc. called whole numbers. The set of whole numbers is denoted by W. Thus, W is equal to 0, 1, 2, 3, 4, 5, 6 up to infinity. Infinity means there is no largest whole. What is the least whole number? 0. Properties of whole numbers. The properties of whole numbers as follows. The number 0 is the first and smallest whole number. All natural numbers along with the 0 called whole numbers. There is no least or greatest whole number. There is no longest or largest whole number since they are infinite. Okay. There are infinitely many are uncountable numbers of whole numbers. Okay. All natural numbers are whole numbers. Do you agree with this? All natural numbers are whole numbers. Because natural numbers are in whole numbers only. Okay. Each number is one more than its previous number. Is it? All whole numbers are not natural numbers. Isn't it? Because 0 is there in the whole number. Example, 0 is a whole number but it's not a natural number. Got it? This is about the whole number. Natural number means is counting from 1. Whole number means counting from 0. Let us see now integers. Do you know, children, what do you mean by integers? See, on the screen you can see integers means 0, 1, 2, 3, minus 1, minus 2, minus 3. See negative numbers. You already see negative numbers where you can observe negative numbers, isn't it? 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, etc. Like that. These are called integers. Between 0, okay, right hand side you will have positive integers. right, left hand side you will have negative integers. Okay, got it. Okay, negative numbers. Where do you see negative numbers? Positive numbers I already see that. Okay, where do you see? You can see the depth of the ocean. Depth of the ocean can be measured from the seabed. It's a minus degree, minus 3 meters, minus 4 meters, like that. Depth of the ocean. Above the sea level is positive, below the sea level is negative, like that. Got it? Okay, temperature. You might have seen that 0 degree temperature. Where do you see 0 degree temperature? 0 degree temperature you can see in the refrigerator, because it's in ice state. Ice, that is refrigerator. Below that 0 degree temperature, minus degrees centigrade. You might have seen sometimes in Antarctica, on different continents, you will see minus centigrade. Okay, minus 5 degree, etc. So these are all importance of negative numbers. Children, positive integers and negative integers, you can see left hand side you can see negative, right hand side you can see positive, 0 in the middle. Next we have a rational numbers. What are rational numbers? All numbers including natural numbers, whole numbers and integers. Number of the form of p by q. Children, all fraction you might have observed in the lower classes, fraction. Okay, you might have heard that fraction. Fraction is called rational number, but all fractions are not rational number. For example, whole number. When we take the whole number minus 3, it's not a fraction, but it's a rational number. Why it is? Means p by q. We can express in the form of p by q, where q is integer, p and q are integer, and q should not be equal to 0. Okay, so these are all called. Here p and q are integers. Example for rational number: minus 5 by 6, 11 by 5, 2 by 15, etc. 0 is also rational number, 1 is also rational number, 100 is also rational number, minus 3 is also rational number, because so we can express that in the p by q form. For example, 100 by 1. Okay, so 0 by 1, but 100 by 0 is not defined. Okay, 1 by 0 is not defined. So that's why the condition for rational numbers q should not be equal to 0. Got it, children? Okay, so real life example of rational number, you can see parts of a whole fraction. You can see the height of a height of a person. Okay, it may be in the form of 1.5 meter, you can see that. And a recipe, when you do some recipes, chef might have used the different types of measure, like for example half cup of flour, and 3 by 4th cup of water, 1 by 4th cup of milk, like that. So they'll use that rational number. Okay, while doing the cooking. Okay, so these are all some example, real life examples of rational number. Okay, now we'll see that number line. You might have learnt about number lines, isn't it? Number line means the numbers which are on the line. Okay, line you already know that. Line you know that. Okay, so numbers which are present on the line is called number line. You can see there is an integer number line 0 in the middle, and left hand side positive integer, right hand side negative integers. Okay, got it? Okay, next what we have? We can represent the numbers on the number line. You can see some rational numbers are represented. The values would be between 1 and 2, between -1, -2, etc., between 3 and 4. So rational numbers represent. You already done in the 8th standard. Do not worry about that. You already done it. Okay, so how the number lines? Any numbers. You can take natural numbers 1, 2, 3. You can see 1, 2, 3 left. You observe right hand side itself. The whole number it starts from 0, 1, 2, 3. Integers -3, -2, etc. Rational numbers, like that. So we can express all the numbers on the number line. Okay, now let us see the properties of rational number. What are the properties you have? Commutative property. A plus b is equal to b plus a. One example, 3 plus 4. What is the value of 3 plus 4? 7. Then 4 plus 3 is also 7. So this is what we call commutative property. So multiplication, addition and multiplication. What is multiplication? A into b is equal to b into a. For example, 6 into 7 is 42. 7 into 6 is 42, like that. So that is a commutative property. Reversing also you will get the same answer. Associative property, grouping number differently, then you will get the same answer. Distributive property, distributing, you will get the answer. LHS is equal to RHS. Identity property, for example, 0 is added to any number, you will get the same number, that is identity element for addition. 1 is multiplied to any number, you will get the number only, that is multiplication identity. Inverse property means a number is subtracted from the same number, you will get 0. A number is divided by the same number, you will get 1. So this is inverse property. So these are the properties you have learnt in a class 8. Okay, the domain of the rational number. What a rational number would be? You can see the small circle which consists of natural number 1, 2, 3, and the big circle which is over on the small circle, that is 0, whole number 0, 1, 2, 3. Then you can see the another bigger circle, integers, and the rational numbers -1, -2, -3, rational number of 0.7, like that. So this is how you can represent the numbers. Okay, so now you can see that all, for example, natural numbers are 1, 2, 3, whole numbers are 0, 1, 2, 3, integers -1, -2, -3, etc. So that you can represent. Okay, next type of numbers we have irrational numbers. Okay, so this is a new concept for you. A rational number might have been done in a class 8 itself. Okay, but up to rational numbers we got in the class 8. Now class 9, it's very important to learn irrational numbers. What is this irrational number? Children, the difference between rational and irrational. Rational means we can predict, for example, a behavior of a children. For example, if I know a student, if I given a homework for a student, he will do the homework. I agree with, I just have a hope that he will do the homework. Then tomorrow when he comes with the homework, he has done the homework means, then I can predict easily, he always do the homework. For example, another student is not doing the homework. One day he does the homework, another day he will not do. Okay, so again for 3-4 days he will not do homework, then he will do the homework, like that. If he keep on changing, then I cannot predict him properly. Prediction, how it comes because by regularity and punctuality. So then I can say that, oh, this fellow will be completing his homework daily, I can trust him. But when I say that that fellow is not completing properly homework, then I cannot predict that. Which can be predicted, they are all rational number. Which cannot be predicted, they are all irrational number. Irrational means we cannot predict a number. For example, one example I'll give the rational number 0.5. What is 0.5? It will stop. Okay, so we can predict that number is same, it will not change. So that is rational number. Pi is a rational number. So we cannot predict the, after the point we cannot predict the decimal system, it will be changing continuously. You can observe here. Pi is the circumference of the circle divided by diameter. You can see there the number how it goes. Okay, after 3.1415926, like that it is going, different numbers are going. So that's why we cannot predict. You can also see that root 2 is a rational number. So root 2 also, the after decimal point we cannot predict the number of decimal how it goes. What are examples of irrational number? Irrational numbers example, you can see what are the examples of irrational numbers? Pi is a one irrational number. Euler number, you will come to know later because it is you're going to study in the college. Then root 2 is an irrational number. Then another is golden ratio, that is also irrational number, 1.6 something. Children, I'll give a homework, just go and check in the internet what is golden ratio. what is golden ratio. Okay, so golden ratio means in the nature also everything is built out of mathematics. In nature also you can see the prediction of golden ratio. You can search there. Now we'll see what is the value of root 2. Root 2 is 1.41421356230951. Root 3 value 1.73205080. See children, here non-terminating and non-recurring decimals. What do you mean by the word non-terminating? Non-terminating means it never stop. For example, non-stop bus. Non-stop bus means it never stop anywhere. It reaches the final destination. That is non-stop bus. Like that, non-terminating. Terminate means it will stop. Non-terminating is never stop. It continues, like it goes on like that. Okay, so non-recurring. What do you mean by recurring? Recurring means repeating. Repeating the same thing is called recurring. For example, 0.3333, 0.33333 recurring decimals. You might be knowing that. Okay, so they are called recurring. Non-recurring means it never repeats. So what is irrational number? If anybody asks you to say what is irrational number, you can say non-terminating and non-recurring decimals. What are irrational number? Non-terminating and non-recurring decimals. Got it? Okay. Now, the thing is, now what you are going to say then? Real numbers. Okay. What do you mean by real numbers? Real numbers means including all the numbers are called real numbers. See here, natural numbers, whole numbers, integers, rational number. Okay. Here you can see irrational number separately. Rational numbers is separate, irrational number is separate. So when you club together, you will get a real number. So whatever number you are going to have, that's all real number now. Okay. So how the real number looks? You can see the chart of real number system. Irrational number pi, root 2, root 5, root 77, root 150. These are all irrational number. You can see here natural numbers. Everybody knows what are natural numbers 1, 2, 3, 4, 5. What are whole numbers 0, 1, 2, 3, 4, 5, 6. What are integers minus 3, minus 2, minus 1, minus 0, 1, 2, 3, 4, etc. What are rational numbers? See rational numbers, you can see 9.3 bar. Bar means what is bar? It repeats, recurring. Then 0.25, 0.121212, like that, 0.88888. All integers also irrational numbers only. Root 16 is a rational number. Okay, 1 by 3 is a rational number. Like that you can write it. So here, what are rational number? Rational numbers are the numbers which can be expressed in the form of p by q, where p and q are integers and q should not be equal to 0. What are irrational numbers? Which cannot be expressed in the form of p by q. For example, pi, root 2, root 3, etc. This is a number chart, real number chart. Rational, irrational, integers ಅಲ್ಲಿ positive, negative integers, non-integers ಅಲ್ಲಿ terminating on, recurring on, 0 natural numbers. This is a chart of that. Again, finally, we recall what we have learnt. What is this? Natural number 1, 2, 3. 0 means whole numbers. Integers means 1, 0, 2, 3, minus 1, minus 2, minus 3. Rational number minus 3, minus 2, minus 1, minus 1 by 3, etc. Terminating decimal, non-terminating, repeating decimals. Okay. Real numbers means rational numbers plus irrational numbers. Rational numbers plus summary. What we have learnt? Okay, natural numbers from 0 onwards, except 0, everything is a natural number. Whole numbers means 0 will be there. Integers, collection of whole numbers, negative numbers are called integers. Examples are given. Okay, so rational numbers which can be expressed in the form of p by q. Irrational number means it cannot be expressed in the form of p by q. So non-terminating, non-repeating decimals are called irrational number. Number line, you already know that. Method of find two rational numbers between the numbers. Okay, so we will learn how to, you know already, how to represent. Okay, Now there is a clock here. You can see the clock. Can you find the numbers in the clock? Okay. So can you find it? Can you find the numbers? See, you already know what are the numbers present in the clock. Okay. What are the numbers are there? What numbers are there in the clock? 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So here some everything is in 9 only. Okay, I can see. Can you predict that? What are the things are there? Now I'll give some hints there. You can see 9 plus 9 by root 9. 9 plus 9 plus 9 by root 9. What is the value of root 9? Root 9 is 3. Okay, when you divide 9 by 3, what you will get? 3 only. So 9 plus 3? 9 plus 3 is 12. Okay, like that. See, 9 by 9 is 1. 9 by 9 is 1. Because you will cancel. 9 cancel 1. 9 plus 9 is 18. 18 by 9 is 2. Isn't it? So, see the beauty of the numbers. Okay. 9. Root 9. What is the value of root 9? 3. Okay. So, here root 9 plus 9 by 9. So, that means 3 plus 1 is 4. 9 root 9 factorial minus 1 9 by 9. See children, factorial, what do you mean by factorial? Factorial means it's nothing but 3 factorial. 3 factorial, 3 into 2 into 1. What is 3 into 2 into 1? 6. 6 minus 1 means 5. Okay. 9 minus 3. Again 9 minus 3 is 9 plus 3 is that. 9 minus 3 is 6. Here 9 plus 1 minus 3. 9 plus 1 is 10 minus 3 is 7. Okay. Then 9 minus 1 is 8. Okay. 9 already is there. 9. 9 plus 1 is 10. 99 by 9 is 11. So it's very easy. So how rational and irrational? Is it any irrational number is there? Can you predict any irrational number? No. No irrational numbers are there. So here only rational numbers are there. Only 9 presenting 9. You can also create such a clock. Okay. Okay children. Now so you understood that what are the number system, what type of numbers are there, and what are rational numbers and what are irrational numbers and all. Okay. Now see the homework. What are the homework? What are integers? Give an example. You already know that. So, is 0 is a rational number? Justify. Are all whole numbers are rational numbers? Yes or no? Are all whole numbers a rational number? Yes or no? Give any two differences between rational numbers and irrational numbers. Give any two differences between rational numbers and what are real numbers? What are real numbers? Got it children? So this is what you have to do the homework. So this is the first class, that's why we are not troubling you. See, so you can make easy mathematics, you can make easy. Don't worry, this kind of you will just enjoy the mathematics, you will not feel bored, you will enjoy the mathematics. Okay, any doubt children? No, see the map of number system, what is number, you can easily remember. Look at the picture, real number system, how it is. You can easily remember natural number, whole number, integers, rational number, irrational numbers. So this club together we call real numbers. So here root 2 is a irrational number. Why it is irrational number? Because it is non-terminating and non-repeating or non-recurring decimals. Root 3 is also irrational number. Okay, so find out such irrational numbers. Children, here 5 pi Euler number and then golden ratio. Okay, so Euler number and golden ratio. So what is golden ratio? Actually I told this, what is golden ratio. Can we see what is golden ratio, how it is very useful. Everybody knows golden ratio. Find out what is the golden ratio. Ratio means what? Ratio means 2:3. You can see 2:3 are called ratio. Is it? 2/3. Its ratio can be written as 2:3. Golden ratio. See the beauty of nature, children. How golden ratio is formed. How mathematics is very we'll see this one everywhere. You can see golden ratio. Okay.
When I learned about this math ratio, it changed my life. Okay, so I'm going to explain in this video a math and design phenomena called the golden ratio. It's also referred to as phi. So what is the golden ratio? Well, to help explain it, I'm going to put out this sequence of numbers called the Fibonacci sequence, which is really just the golden ratio in a sequenced numeric form. Now, to arrive at this golden ratio sequence of numbers, we just need to follow a basic math formula. And I'm not a math person, so we're just going to keep this very simple. Okay, so you just start with 0 plus 1 equals 1. And now to get to the next number in the sequence, you take the sum of that simple equation and add it to the last number in the equation. So 1 plus 1 equals 2, and then 1 plus 2 equals 3. And it's around this point that the ratio actually starts showing up. And as we continue to do this formula, we start arriving at a set of numbers. So 2, 3, 5, 8, and you see what we're doing? We're adding the sum of the equation to the last number in the equation, and we arrive at this sequence of numbers. And it's interesting that this sequence and ratio actually remains consistent no matter how long you follow this mathematical formula. And so this sequence continues to expand outward around the rate and the ratio of 1 to 1.6. Now, to help give you an idea of what a 1 to 1.6 ratio is, compare it to a 1 to 1 ratio. So to make a 1 to 1.6 ratio, you just envision a little more than half of the initial line added to the line of the other side. All right, so this ratio of 1 to 1.6, and this is the ratio that's called the golden ratio, a 1 to 1.6 ratio. So this is what the golden ratio looks like as a rectangle, 1 to 1.6. And if we were to start making incremental golden ratio points within that, we can get an idea of what a spiral looks like when it expands outward at the same measured sequence. Now, this is all well and good, but what does that have to do with everyday life? Well, a lot, actually. And that's because when we look to nature, we see that so many things flourish when they go to the golden ratio design and when they follow this sequence. Growing and expanding to the rate of the golden ratio spiral allows the maximum amount of rain to be directed down to the roots of many plants. And remarkably, when you study nature, you see the golden Fibonacci numbers like 3, 5, 8, 13, all of that again and again in the seed pattern spirals of plants, as well as in the number of petals. Next time you're bored and have a sunflower, try counting the number of seeds in the sunflower spiral, the golden ratio. Or maybe try something else with a spiral, like a pine cone or pineapple. So we could spend all day counting the seeds of flowers and plants and fruit. I mean, you get the idea. But we don't just see this golden ratio sequence on a small scale. This ratio is the mathematical sequence in the spirals of our storms, tornadoes, hurricanes. These all spin in this golden sequence, 1 to 1.6. Even the waves can be measured using this ratio. But it doesn't stop there. Modern technology continues to be mystified by the far-reaching scope of the golden ratio. From the alignment of the planets to the spirals of our Milky Way galaxy. as well as the spirals of other ratios in planets. Now let's take this closer to home. I want you to hold out your arm and look at the distance between your shoulder and your elbow, and then from your elbow to your fingertips. Notice how your elbow, from your shoulder to your elbow is 1, and then from your elbow to your fingertips is 1.6. Pretty crazy, huh? But it doesn't stop there. Now take that further. The distance from your fingertips to your wrist is 1, and from your wrist to your elbow is 1.6. Keep it going. From the furthest tip of your finger to the bottom of your fingers is 1, and from the bottom of your fingers to your wrist is 1.6. Now check out the spacing of your knuckles. 1 to 1.6. Are you getting freaked out yet? Think about this. The head to your belly button, 1, and then belly button to your feet, 1.6. From your toes to your knees, and from your knees to your hips, golden ratio. Ever wonder why your 2 front teeth are so much bigger? Golden ratio. The pupils of your eyes, I mean, you name it, your whole body is the symphony of the golden ratio. In fact, as you are listening to this video, the sound waves are passing through your ear in a perfect golden spiral. Scientists have discovered that the golden ratio pattern is necessary for the human brain, the neural system, our sense organs, and our lung system. The golden ratio sequence is even in the helix of our DNA, and it forms the very rhythm of our heartbeat pattern. This is pretty amazing if you ask me. The universe is an incredible place. And to think that these beautiful intricacies of the world all hang on a stacked razor's edge with the incomprehensible fine-tuning of all these precise constants and quantities which allow the universe to begin to exist. I mean, it's unfathomable. No wonder we are naturally bent to worship a higher creative power. I mean, we are fearfully and wonderfully made, and we live in a universe that is designed and hardwired to be life permitting. I mean, speaking of which, I think it's interesting that the golden ratio also comes up in the ancient biblical text. Scholars have noted that when you consider design measurements of things like Noah's Ark and the Ark of the Covenant, the golden ratio is an exact match to the measurements. Pretty interesting. Okay, so we've seen how the golden ratio is embedded into our life and even into our own heartbeat. So naturally, it's going to affect our aesthetics and the arts. It is believed that the Greeks used the golden ratio to achieve ideal acoustics, and many instruments are actually designed with the ratio. When you look at the amount of black keys and white keys on a piano, it should be no surprise that you see the golden ratio, and that's because the musical scales and notes align with the Fibonacci sequence. So scientists, mathematicians, and artisans have been aware of the golden ratio and have been incorporating it into their architectural and artistic designs throughout history. For some reason, designs tend to look better when composed and designed with the golden ratio. Look at iconic, ideal Greek temples like the Parthenon in Athens. You can see that they use the ratio again and again. Painters have also been incorporating the golden ratio into their artistic designs because it gives the composition a je ne sais quoi. Leonardo da Vinci was obsessed with it. So was Michelangelo. Even in the 20th century, you see ratios being used in painting, whether it be in the dimensions of the canvas or the placement of the focal point. And by the way, the golden ratio is one of the reasons artists don't like to line everything up in the center. But you don't have to go to Greece or to the Louvre to appreciate the golden ratio in human design. I mean, just look around your house or go to the grocery store. The golden ratio is used in product design, logos, and in branding all the time. It's a ratio that, for some reason, is pleasing on the eye, and it can be a great template for solving multiple design problems. I remember when I first started learning about the golden ratio, I began to see it everywhere. And it's really remarkable with how it comes up in nature and in the design world, and how artists can greatly improve their designs by using its sequence. So now that you know about this mysterious sequence that pops up again and again, now go out, and I want to challenge you to go and look and find places where you see this ratio. You don't necessarily have to take around a measuring stick, but take pictures and notice where you see this ratio come up in design and in nature, and I think you will be surprised. And perhaps even this newfound awareness, it might even change.
Okay, children, did you enjoy the video? Okay, so here in our daily life, you can see many mathematical concepts, okay, that you can observe. uh, See, now what we have seen, the golden ratio means 1.6, 1 to 1.6, and that is an irrational number. So this is how we can find some of the number, some of the concepts in the mathematics and nature also. You can in our daily life also, we are knowingly unknowingly we are using that, okay. But you should know that why we are using it and what is the concept behind it. Take everything, whatever you think, take anything with you. You just conceptualize that thing, so then only you can learn it. Okay, children, so today we'll end the session. um, okay, I hope you understood the introduction class of class 9, number system. So next we'll start the actual lesson. Okay, thank you, children.